Hey guys, welcome back. I hope you've had a nice restful weekend. Yesterday we just had the 8 review problems and you submitted those on a Google form so you could get immediate feedback and know how you were doing. Remember, starting this week I have virtual office hours every day from 8:30 to 9:30. So that's a chance. I posted that link on Classroom. If you need to talk to me, then please join those office hours during that time. Also, if you are struggling, you know you can always shoot me an email. I will happily answer those. If you are behind on any of your work, get in touch with me, please. I've reached out to a few of you. Most of you are staying caught up and doing great, but if you are falling behind, please get in contact with me and let's figure out a plan moving forward. So today's lesson is really going to cover the next few days, and it's something that if we were in class I would have printed these notes for you because I'm looking at word problems. So what I will actually do is at the end I will post a PDF of these slides on Classroom as well. That way you have the original problems you can go back and look at without having to pull up the video when you go to do your homework. So a few things that we're talking about here. The first one is what's called the change of base formula. We have done problems before. We talked about how you have the log base 10 and the natural log buttons on your calculator, but if I gave you log base 2 of 5, you didn't have a way to answer that. Now some of you have figured out ways in your calculator to get those answers. However, not every calculator has that ability. So to level the playing field here, if I give you something where the base is not 10 or E, so it's not one of the 2 main buttons on your calculator, if I ask for a decimal, you have to convert it using the change of base formula in order to get credit for your answers. So you can take whatever base you have, convert it to whatever base you want. So for us that would mean log base 10 or the natural log. So if I had this, log base 10 is just log. You do it log of the argument divided by the log of the current base. Each of those gets their own log. Or you can change them to natural logs. Both ways you get the same answer. So then you just enter that on your calculator. Remember, every time you push the log button it opens a parenthesis, so don't forget to close that. And I'm going to ask you to round to 4 decimal places on MathXL. Just make sure you're reading the question. It does always specify how many decimal places it wants you to enter. So if I put this on test or quiz, I will say that you must show work in order to get your answer. And what I need is this one line right here, showing me one of these, log 5 over log 2 or ln 5 over ln 2. Okay. So just a couple examples. Log base 5 of 7. So that would turn into log of the argument, so log of the big number over log of the base, or log of the big number over log of the small number. So then on your calculator, log 7 over log 5 is 1.209, round up, so 2091. You also have the option of going to a natural log, so ln, so if I did log base 2 of 0.1, you could do ln 0.1 over ln 2 if you preferred. It does not matter, you get the same answer both ways. And that gives me negative 3.3219. Okay. The next thing that we're going to do is just look at applications, scenarios where you use logs to solve problems. One of those comes up in science classes, talking about pH. If you're in a chemistry class, this is something that you've done before. So if I'm dealing with the pH of a solution, the formula for that is negative log H3O plus. I would not ask you to memorize this formula. I would give it to you. It's just something that you would be expected to use. H3O plus is sometimes referred to as the hydronium ion concentration. And then pH, I think we're familiar with. It tells you how acidic or alkaline a solution is. So we'll just look at an example of that. I want the pH of a solution with H3O plus equal to 2.5 times 10 to the negative 4. So I'm just plugging into my formula. I told you pH was a negative log of the H3O plus. That was the formula on the last slide. So it's a negative log 2.5 times 10 to the negative 4. And then you just type that in your calculator. Negative log 2.5 times 10 to the negative 4th power. Typically we round pH to 1 decimal place, the nearest tenth. So this has a pH of 3.6. Part B. This time I gave you the pH and I'm asking for the hydronium ion concentration. So using my formula, the pH is 7.1 equals a negative log H3O plus. So I'm asking you to solve a log equation here. You have to solve for this inside. The H3O plus is what you have to find. What I'm going to do first of all is divide over my negative. Get the log by itself. And then we know the definition of a log, we could change it to exponential. So that means 10 to the negative 7.1 equals your H3O plus. If you type that in your calculator, it's still going to give you an answer in scientific notation, and that's fine. It tells me 7.94 e negative 8, that means times 10 to the negative 8. So that is my approximate hydronium ion concentration. Okay, our next example. If 800 grams of a radioactive substance are present initially, and 2.5 years later only 400 grams remain, how much of the substance will be present after 4 years? This is talking about what's called exponential growth and decay. And exponential growth and decay always follows the same pattern. It looks like this. Y is the amount present at a given time. Y sub 0 is the initial, the amount at time 0. K is a constant. If it's growth, K will be positive. If it's decay, K will be negative. So if I'm looking at this, 800 grams is what was present initially. So that is my Y sub 0. I don't give you the constant, but what I do is give you one particular point that we can use to find our constant. After 2.5 years, so when my time is 2.5, we have 400 grams remaining. So at that particular point, my Y is 400. Now I need to solve this for K. So if I divide my 800, I get 0.5 equals e to the 2.5k. We know how to solve these exponential equations now, though. We add a log to each side. Because it's an e, I'll add an ln to each side. The benefit is the ln and e drop. Then I can just divide my 2.5 And then using our calculator, ln 0.5 divided by 2.5 is, I'm going to round this to the nearest thousandth. So my equation here for this particular substance, the amount at any given time, we started with 800, my K is negative because it's less substance as time goes on, T. So this first part was just to find my equation. You're going to have some of these on MathXL and it'll say part A, find the exponential model. Here is your model. And then it'll ask you to use that model, use that equation to answer some question. So now I want to know how much will be present after 4 years. So I'm looking for Y. And my time is 4. So put that in your calculator. And we get 264, let's round to 3 decimal places again, 0.175 grams. And again, on the MathXL, you would just have to watch the question to how many decimal places to round to. Alright, so that one was a little more challenging, had a few more steps. I'd like to try another one like that. Okay, so very similar question, similar setup. I just want to walk through this again. So if 600 grams of a radioactive substance are present initially, so that's my Y sub 0, my starting amount. For the equation, we need our Y sub 0 and our K. Remember, the equation is Y equals Y sub 0 e to the kt. 3 years later, that's a t, 300 grams remain, that's my y. So I'm going to have to use those points to find my k. So my y is 300, my initial amount was 600, e, I don't know k, but this is after 3 years. Divide by my 600 and we get 0.5. Add an ln to each side. Ln and the e drop. So divide by 3. And again, your answer will vary depending on how many decimal places you use. I'm going to go to 3. So my k is negative 0.231. So my model, my exponential model is y equals 600 e to the negative 0.231 t. Then I'm asked how much will be present after 6 years. So if we plug in a 6, and then just use your calculator, I get 150.044 grams. Okay. I'm going to look at another problem. I'm actually going to do this out of order, I think. I'm going to jump to what I have as example 5 in my notes. The amount of radiocarbon, or carbon-14, present after T years is given by this equation. Y sub 0 is the amount present in living plants and animals. So, in other words, this time I have given you the original equation. Now I'm going to ask you questions about it. Part A, I want the half-life. The half-life is when you have half of what you started with. Now, I didn't give you an actual number for what we started with, but if I start with y sub 0, then my half-life would be when I have half of that. So your homework will ask you to find the half-life of something. It's just when you have half of what you started with. So my y is 1/2 of the y sub 0. First thing you would do is divide by y sub 0. And you just get the 1/2 or the 0.5 if you prefer decimals. So really the last two questions, we had the half-life come up. I gave you the half-life when I told you how long it took to have half of what you started with. I just phrased this one differently. So now I'm solving for t, so add the ln to each side. Divide that over. We put that in, we have the natural log of 0.5 divided by negative 0.000216. And my time I might ask you if I said round it to the nearest year. This is 5,700 years before this happened. So just watch the directions on how to round. Part B tells us charcoal from an ancient fire pit on Java contained 1/4 of the carbon-14 of a living sample the same size. Estimate the age of the charcoal. So I'm using the same equation that was given in the problem, but instead of asking when I have half left, we have 1/4 left. So my y is 1/4 the y sub 0. So same process, first divide your y sub 0, then we'll add our natural log. Then the ln and the e cancel. So we have natural log of 1/4, and we want to divide that by the negative 0.000216. So this one took about 11,400 years. The last examples I have are some interest problems. We've done interest before. I'm just asking you to solve for different things. Remember our two options for calculating interest. We had our regular compound interest and our continuous compound interest. So if I want how long will it take, so I am looking for t. For the money in an account that is compounded continuously, so that tells me I'm using this one, at 5.75%, so my rate is 0.0575, to double. So you have options. I didn't tell you how much money you started with. We've talked about this before. You guys usually just preferred to make up numbers. So if my P was 100, I want it to double, so that means my A would be 200. Divide my 100 over. Add the ln. And we can divide by the 0.0575, so we have natural log 2 divided by 0.0575. And you get 12.0547 years. And of course you would have to look at the directions to know quite how to round that. Alright. Last problem, along the same lines, but I've switched it up. How long will it take $1,000 invested at 2% interest compounded quarterly to grow to 2,700? So what I have right now is my P, that's 1,000. My A, what I want to have in the future, is 2,700. My R, 2%, would be 0.02. Compounded quarterly, so that means my N is 4. It's not continuous interest, so we're using this one. Plug in everything we have. And we're solving for T. So you could divide your 1,000 over. You could also simplify on the inside of that. So a couple steps we're going to take here. If we divide by the 1,000, we get 2.7. If you do 1 plus 0.02 divided by 4, so just working the inside of the parenthesis, that's 1.005. We have to add a log here. It doesn't matter if you do the ln or not, because I don't have a base of e. Okay. Remember, with that, the exponent will come down. So then to get my t by itself, I can divide by my 4 log 1.005. And we get t equals log 2.7. Make sure for the denominator, you'll have to use a set here as well as your log when you're looking at your parentheses. And we get 49.787 years. Okay, so remember, if you have questions with this, you can use my Zoom office hours or email me for anything. The assignment for this section is on Math